Aerostats. These are lighter-than-air vehicles that can float in the atmosphere by using buoyant gases such as helium or hydrogen. They can be used to create platforms or habitats that can support human life and activities. Aerostats can be tethered to the ground or to each other, or they can be free-flying and controlled by propulsion systems. Some examples of aerostats are balloons, airships, and blimps. Space elevators. These are hypothetical structures that connect the Earth's surface to a point in geostationary orbit, where the orbital speed matches the Earth's rotation. A space elevator could allow access to high altitudes without the need for rockets or aircraft. A space elevator could also serve as a base for building and launching flying cities or islands into orbit or beyond. Some challenges of building a space elevator are the enormous cost, the material strength, the safety, and the environmental impact. Anti-gravity. This is a hypothetical phenomenon that counteracts or cancels out the effects of gravity. Anti-gravity could enable flying cities or islands to levitate without any external support or propulsion. Anti-gravity could also allow for novel forms of architecture and transportation. However, anti-gravity is not supported by any known physical laws or evidence, and it is considered to be pseudoscience by most scientists.
Nuclear fusion. This is the process of fusing two lighter atomic nuclei into a heavier one, releasing a huge amount of energy. Nuclear fusion is the same process that powers the sun and other stars. If humans can harness nuclear fusion on Earth, it could provide a virtually unlimited source of clean and safe energy. However, nuclear fusion is very difficult to achieve and sustain, and it requires high temperatures, pressures, and magnetic fields. There are several ongoing research projects and experiments to develop nuclear fusion reactors, such as ITER and SPARC. Solar power satellites. These are satellites that collect solar energy in space and beam it down to Earth using microwaves or lasers. Solar power satellites could provide continuous and reliable energy, as they are not affected by weather, seasons, or day-night cycles. However, solar power satellites are very expensive and complex to build and launch, and they pose some technical and environmental challenges, such as interference with communication systems and wildlife. Zero-point energy. This is the hypothetical energy that exists in the quantum vacuum, even when all matter and radiation are removed. Zero-point energy is based on the idea that quantum fluctuations create virtual particles that pop in and out of existence. If humans can tap into zero-point energy, it could provide an infinite and omnipresent source of energy. However, zero-point energy is highly speculative and controversial, and there is no evidence or theory that supports its extraction or utilization. This is what zero-point energy would look like on a larger scale.
Electric aircraft. These are aircraft that use electric motors or batteries to power their propulsion systems. Electric aircraft could offer a fast, quiet, and low-emission way to travel between cities, especially for short to medium distances. Some examples of electric aircraft are Lilium Jet, Spengweight Yen, and Airbus City Airbus Next Gen. Flying taxis. These are electric vertical takeoff and landing vehicles, eVTOL, that can carry passengers or cargo in urban areas. Flying taxis could provide a convenient, flexible, and on-demand mode of transportation that avoids traffic congestion and road infrastructure. Some examples of flying taxis are Volocopter, Joby Aviation, and EHang. In the future, flying taxis will look something like this. Hyperloop. This is a proposed mode of transportation that involves sending pods or capsules through a near-vacuum tube at very high speeds. Hyperloop could enable ultra-fast, safe, and energy-efficient travel between cities, especially for long distances. Some examples of Hyperloop projects are Virgin Hyperloop, Hard Hyperloop, and Transpod. Trains that fly over tracks can also improve transportation. In the future they might look something like this.
One possible way that vehicles like cars and trucks will be changed in the future to adapt to living on platforms is by becoming more autonomous, connected, electric, and shared. These are the 4 trends that are transforming the future of mobility, according to a report by McKinsey. Autonomous vehicles, AVs, can drive themselves without human intervention, using sensors, cameras, and artificial intelligence. Connected vehicles, CVs, can communicate with each other and with the infrastructure, such as traffic lights, signs, and platforms. Electric vehicles, EEVs, use batteries or fuel cells to power their motors, reducing emissions and noise. Shared vehicles, SVs, can be accessed by multiple users through platforms or services, such as ride-hailing, car-sharing, or carpooling. By adopting these 4 trends, vehicles like cars and trucks could become more efficient, safe, convenient, and affordable for living on platforms. For example, AVs could reduce the need for parking spaces and optimize the traffic flow on platforms. CVs could enhance the coordination and integration of different modes of transportation on platforms. EVs could reduce the environmental impact and energy consumption of vehicles on platforms. SVs could increase the utilization and accessibility of vehicles on platforms. Another possible way that vehicles like cars and trucks will be changed in the future to adapt to living on platforms is by using hydrogen as a fuel source. Hydrogen is a clean and abundant energy carrier that can be produced from renewable sources, such as water or biomass. Hydrogen-powered vehicles, HPVs, use fuel cells to convert hydrogen and oxygen into electricity and water, emitting no harmful pollutants. Hydrogen can also be used to store and transport energy across platforms. By using hydrogen as a fuel source, vehicles like cars and trucks could become more sustainable, resilient, and versatile for living on platforms. For example, HPVs could have longer driving ranges and faster refueling times than EVs. Hydrogen could also provide backup power or heating for platforms in case of emergencies or blackouts. Hydrogen could also enable new forms of mobility on platforms, such as flying taxis or drones.
Sorting and recycling waste, robots could use artificial intelligence, cameras, and sensors to identify and separate different types of waste, such as plastic, metal, paper, and organic materials. This would reduce the amount of garbage that ends up in landfills or incinerators, and increase the efficiency and quality of recycling. Some examples of robots that can sort and recycle waste are BrainCorp, Whiz, and DustBot. Collecting trash from streets and waterways, robots could use mobility, navigation, and odor detection to locate and remove trash from public areas, such as parks, sidewalks, rivers, and lakes. This would improve the cleanliness and aesthetics of the city, as well as prevent pollution and harm to wildlife. Some examples of robots that can collect trash from streets and waterways are TrashBot, WasteShark, and ClearBot. Disinfecting surfaces and spaces, robots could use ultraviolet light, chemicals, or steam to sanitize and decontaminate surfaces and spaces, such as floors, walls, furniture, and air ducts. This would reduce the risk of infection and disease transmission, especially during public health emergencies. Some examples of robots that can disinfect surfaces and spaces are UVD Robot, Neo, and CleanFix. Thank you for watching what may happen in the future.